Hi, Year 10. Today we're looking at 7F, exponential and logarithmic graphs. This little exercise to have a look at pretty much flows on beautifully from our last topic, which was functions, the way that we looked at domain and range and looked at sliding graphs along the left and right, along the x-axis and up and down the y-axis is going to happen with our graphs today. So we're going to use all our functions knowledge and apply that to the logarithm as well. So if you have a look at the two graphs below here, what you will notice, well, I'm hoping you'll notice, is that the blue ones look pretty familiar for you. They're our exponential graphs. That's what we had a look at in the functions topic. Our exponential here is 2 to the power of x. It goes through the point 0, 1. And what you'll notice is the log, which is the inverse of that graph, the inverse of 2 to the x is log 2 of x, is our red graph. Okay, it is the reflection of our exponential about the line y equals x. So if I was to flip my blue line here over that line y equals x, I'm going to get the inverse graph or the logarithm graph. So it is logged of base 2 of x, and instead of going through the point 0, 1, it goes through the point 1, 0. Okay, so our exponential base and our log of the same base, so in this case 2, would be a reflection about the line y equals x. Now that same thing would happen over here on the second set of graphs here. We have a base 10 on our exponential and a base 10 on our logarithm. So they're the inverse of each other, those two graphs. And what happens then, like we did with our base 2, they would be reflected along the line y equals x. Okay, so if I reflect my line 10 to the x around y equals x, I'm going to get the logarithm, the inverse log base 10 of x. Okay, what we want to have a look at with those sets of graphs are the information in the table down below. So we want to have a look at the domain and the range and some asymptotes and have a look at what happens in each of those sets of graphs. So what we have is our exponential column and our logarithmic column. And there's a lot of similarities in there, but we'll go back to have a look at what's happening in our graphs. So in our exponentials, which are our blue lines here, our 2 to the x and our 10 to the x, our domain is all real x. We have a look at that. All x values can happen for that. For the blue graphs, for our logarithms though, our red ones, that is not the case, is it? Have a look at what's happening there for our domain. We've only got our x happening in the positive side. So our x is positive, or x is greater than 0. Our range, however, if we have a look at what's happening for our exponentials, our range is our y. Okay, so for our 10 to x and our 2 to our x, we're only having parts of the graph that are sitting in the positive y section. So our range for those is y is greater than 0. But for our logarithms, we have a look what's happening here and here in our red graphs. Our logarithms can take any value of y for each of those. So our logarithms are all y values. Okay, our axis crossing point. So remember, our axis crossing point for our exponentials happens here and here. So that's the point 0, 1. For our logarithms, it's 1, 0. Let's have a look at our asymptotes. Now, asymptotes for our exponentials. Let's go back and have a look at the blue lines. What's happening with our asymptotes there? So either thinking back to your functions topic or having a look at what's happening with our graph there. Our horizontal asymptote, okay, the one that goes across this way. On our exponential, we have a look at what's happening in our graph. Our exponential is getting closer and closer and closer to our x-axis, but it doesn't actually ever touch. So our x-axis is one of our horizontal asymptotes. For our logarithm though, we don't have a horizontal asymptote because our graph actually cuts the x-axis. So we don't have one there. But the opposite's going to happen for the vertical asymptote. So in our exponential graph, we didn't have a vertical asymptote. Okay, we could take on any value of y in there. So we're going to keep going with our y values. But for our logarithm, our vertical asymptote is going to be the y-axis. So that logarithm moves down here, gets closer and closer and closer to our y-axis, but it never actually touches it. So we're going to have the y-axis as a vertical asymptote. Now, the next thing in our table here is looking at curvature. The curvature is just talking about what happens as x goes towards infinity or as x gets really large. So on our exponential graphs, let's have a look. As x gets really big, our exponential gets steeper and steeper, doesn't it, on both of those cases. So that's why I've got steeper down there. That's where that comes from. But as x goes to infinity or x gets really large on our logarithm, what we're finding is it's going to start to flatten out. So this part of the graph here, it's going to go around and move that way a little bit. It's going to flatten down. It's not getting steeper. So that's what we'd say here. It's getting flatter for the logarithm. And concavity, or we normally use the word concave, either concave up or concave down. We're going to use that language a little bit more in differentiation, which is coming up as our next topic. But let's see what it looks like here. In the exponential, our concavity is, we look at what shape it is there, it's a concave up. It's looking more like that kind of shape. That's our concave up shape. That's happening here as well. It's what we'd call concave up. The opposite is happening for our logarithm. The shape of the logarithm is more this sort of shape. So it's a concave down, we call that one. But we'll look at that language a little bit more as we move through our calculus topics. Okay. Now, graphical properties. Now, we looked in the function topic a lot about translating our graph in the x direction, either positive or negative. We slid it left or right, and we looked at translating it up and down. Okay, so these are our x slides. These are our y slides, or our y translations. And we also looked at reflecting things. The same rules are going to apply for these two graphs. Well, we looked at the exponential, so you should be pretty familiar with those. The same kind of rules are going to apply for the logarithm. Okay, when we move up, we move down. We'll have a look at those and practice some of those down below here. Okay, so let's have a look at the example here. So we've got y equals a to the x, y equals log of a to the x. It says for the listed functions, fill in the table of values and sketch the curves on the same axes. So to start with, we're going to have a look at our exponentials, 3 to the x, 3 to the minus x, and minus 3 to the x. We're just going to pop in our values into each one of these, get our grid values, and plot the graphs on our axes over here. So I've popped those values in there for you already. So if you want to copy those down into your booklet, that would be very helpful. Otherwise, make sure that you can get those on your calculator, or that you understand what's happening with those. What you'll notice is with our exponentials, we're going through 0 and 1, or we're going through 0 and minus 1 when it's a reflection. Okay, so the first one I want to plot is y equals 3 to the x. Okay, so we're starting at x value of minus 2, which is down here. And we should have a little tiny value of about a 9. So we're way down here, remembering that the asymptote is the x-axis. So we're very close to that axis, but we're not quite hitting it. As we move towards 0 and go to minus 1, I'm getting a little bit bigger, so my number's a third. So I should be about a third of a way through there. And then I'm going to hit the point 0, 1 here. So my graph to start with, it's going to look like this. Okay. When I move to 1, over here, I'm going to be at 3. So I'm going to pop a 3 on my scale up here. So we're getting steep already. I'm way up here. And by the time I get to 2, I'm going to have shot off my graph. So I'm not going to pop that on there. So that's my first one there. That's my y equals 3 to the x. Okay, I'll change colours and we'll have a look at the other one. Okay, y equals 3 to the minus x. Do you remember what that one looked like? See if you guys can pause this and have a go at plotting that for me to start with. Okay, so have a go at doing that yourself. Hopefully you've done that, and I'm going to draw mine now. So my first point here is going to be off the chart. So I'm going to start plotting at this little one here, minus 1 and 3. So I'm back here. If you think what's happening, back to our last topic, when I popped a minus sign up there in the power, it reflected that graph around the y-axis. So my graph is going to be a reflection of the one that is already there. It's going to look like this. Okay, and that's my y equals 3 to the minus x. Okay, now, last one in there. Do you remember what that one looks like? Do you remember what we did for a minus out the front? When there was a minus out the front of the function, that reflected our original function about the x-axis. So I'm going to reflect this black line underneath here like this. Now we need to know that, but in this point we're looking at our x and y box plots, so we can use that as well to do that in this case. So in reflecting that black line, I'm going to be moving along here like this, going through that point 0, -1 now, and down like that, and then my 3 graphs. Okay. We are going to go moving down a little bit further now, and we're going to have a look at plotting graphs and their logarithm with them. So let's have a look at this first one here. We've got x and we've got log of base 2 of x. Okay, so step 1, let's have a look at log of base 2 of x. So we're going to pop each of these x values into the position of x here and figure out what our answer is. So the first thing we've got to do is log of base 2 of 1/4. So I've just rewritten that over here to the side to do some working out for that. Now, log of base 2 of 1/4, we can't pop that in our calculator because it's a base 2. So we need to work out what we can do with that using our log rules. So log of base 2 of 1/4 is log of base 2 of 1 minus log of base 2 of 4. Okay, now thinking about what that means, 2 to the what is 1, 2 to the 0 is 1, minus 2 to the something is 4, that something is our answer, it is 2. Okay, so I'm thinking about what that means in terms of exponentials. Okay, 0 minus 2 is -2. So that's our first answer. I'll pop that in there. Now, if you did not understand what I've done there, that means you need to go back and have a look at that section that we've already worked through where we learnt those rules. Okay, so that's something that you're going to need to reassure yourself that you're understanding that one. Likewise, we can do the same for the next one. If I'm popping a half into there, it's log of base 2 of 1/2. Okay, so I've just moved over to the side to put the working out in there for you. Log of base 2 of 1/2 is, oops, if I can just find my working out again, sorry, is going to be log of base 2 of 1 minus log of base 2 of 2 using our log rules. 2 to the power of something is 1, 2 to the power of 0 is 1. Take away, 2 to the power of something is 2. That means 2 to the power of 1 is 2. So 0 minus 1 is -1, and that's our next one there. Okay, next three are quite easy. I'm going to pop a 1 in there. 2 to the what is 1. 2 to the 0. 2 goes in there. 2 to the something is 2. 2 to the 1. And 2 to the something is 4. It's going to be 2. So there are our values there. And we can plot that one now. Okay, so we'll have a look at plotting log of base 2 to the x in a moment. Before we do that, let's have a look at log of base 2 of x minus 1. Now let's think about what that means. Think back to your last topic on functions. What happened when we replaced the x with an x minus 1? It translated the graph to the right plus 1. So we're going to be moving our graph to the right by 1 unit. What we just managed to do to make it a little bit nicer is we've put values in here that are 1 more than what's up there. So if I pop those in, I'm actually going to be getting the same values that are up there, and you can try those out for yourself, and I'm going to plot those ones now. Okay, so just carefully go ahead and plot those values on your graph. It doesn't have to be perfect, just a little bit of a sketch. In looking at your x values, you've got half, you've got a quarter, so just be careful. I'll do that and we'll compare our graphs. There should be one graph and one that's slid across to the right by 1 as well. Okay, so you can pause the video, compare your graph to mine. Y equals log 2 of x. Does yours look like that? There was a little point up here that said, notice there is no 0. Have a think about what that means. Okay, pause the video if you need to have a think about it. What that's saying, there's no x equals 0. There's no x equals 0 here because what we're finding here is that our y-axis, which is the line x equals 0, is an asymptote. So it's never actually going to touch. So the bottom of my graph, which is a little bit wobbly there, probably needs to look a little bit more like it doesn't touch that axis. Go ahead and draw your next one for me. Okay, and there's my second graph. Again, it's a sketch. It's not perfectly perfect. The top should probably be a little bit further down like this, but that's the gist of the graph. So from x to x minus 1, we've moved the graph 1 unit to the right, or we've translated it 1 unit to the right. This video will end here. I'll upload it and I'll continue with the second video for the next example.